point. Okay, let me see what's going on here. Well, I should be broadcasting, but I'm not actually seeing it here in my... If anybody's actually watching this, just give me a couple of minutes to get things set up and come back. It's 1:15 here in Utah, and we'll start in about 2 minutes. Just trying to get the audio dialed in. What am I doing wrong? Oh, there we go. Yeah. It's just there's a little bit of a lag time, but I'm not seeing my screen being shared on the actual broadcast, so that's a little worrisome. Oh, no, I saw it. It's up there. But I'm actually watching on you. Are you watching on YouTube? Yeah. Oh, okay, cool. For some reason, but you're on. So you're not in Hangouts. You're actually on the YouTube Provo, and you're on the Python, Pandas, Matplotlib. That's the, it's not. It doesn't say machine learning. It says. Okay, cool. Okay, I'm just not seeing the actual screen, but good. Yeah. Okay. Well, let's go ahead and get started here then. This is a data science workshop that we do. And we had 40 people signed up, and I think some people are still thinking we start at 2 o'clock. I decided to change things up a little bit this time, and we're starting at 1:15, going to run till 2, we'll stop, and then there's another video that we'll do from 2:15 to 3:30-ish. What I wanted to show you is, first of all, I'll get my slides up. So last time we had, now neither of you guys was here last time, but we had a guy named Tanner and his wife Sydney that gave a great presentation on Matplotlib and just some Python, Pandas, and some Jupyter Notebook type stuff. She did a really good presentation using binning, and I'd never seen it before. It's a way that you can actually draw different shapes of bins on a plot, and then it's kind of like a heat map, and it's a little bit like clustering. But then when you get into machine learning, there's actual clustering. So we're going to look at that in the second hour. But one of the things that came up is they were trying to write, like in Pandas, I should probably jump into the notebook here, but let me go through the notes here. In Pandas, you tend to want to use the ampersand instead of the and. We had a situation came up where we were trying to do a conditional comparison. How's it going there? And we were trying to, and we just barely started, so you didn't miss anything. Cool. We were trying to do something with plotting where we were looking for 2 different conditions. And when you try to do that, I'll get to an actual example here on the next slide. But when you try to do that, there's 2 different ways to say and in Python and by extension in Pandas. And so if you look at this, part of it is whether you can override it or not. I'm not sure why Pandas prefers to be able to override things, but you don't use and. Like, you don't spell out the A and D in Pandas. You always use the ampersand. And the reason for that is in Pandas, unless you're doing an actual for loop, like if you're doing a for loop in Pandas, you're basically doing something wrong. There's very rare cases where you would want to iterate. And let me just ask, who in the room is familiar with Pandas or Python? Does any of you guys use? Okay, so just one of. Okay, so a little bit. So let me just back up for a second. In Pandas, it's if you ever use R, there's something called data frames in R, and then Pandas is basically the way of doing data frames for Python. And it's a great library. It's something that you really need to know if you want to be a data scientist and be out there, like in the corporate world. We had a discussion last month about how academic stuff tends to be more with R and corporate stuff tends to be more with Python. That's an oversimplification. But basically, Pandas gives you like a data frame, and when you do operations, and we'll look at more specific examples as we go here. But when you do specific operations, you don't want to iterate. Like if you're looking at a column in a Pandas data frame and you're trying to iterate through every value using a for loop, you're actually defeating Pandas' own functionality. Pandas will use multiprocessing. It'll use multiple processors, like parallel processing. As soon as you give it a for loop, it can't do that. It actually limits the process. So basically, the reason I'm bringing this up is to mention that you never want to use for loops in Pandas if you can avoid it. But a lot of what you're doing is saying, like, find me all the values in this table where the state is equal to Utah or the state is equal to Arizona. And so if you were gonna do that, you're looking at an entire. It's actually a NumPy array. Like Pandas data frames are made of NumPy arrays. And if you think about this, an entire array. Like let me go to the. And if you look at the bottom of the slide here, and I actually have got just to mention real quick, I made a red cursor. It's ugly. And I also did this little thing where if you hit the control key, so you can do that in Ubuntu, pretty much built-in functionality. But if we look at some of these commands here, if you're looking at a data frame and you're saying, data frame A, column X, you want to find all the values where A of X is equal to 1 and A of Y equals 10, you'll get this error or some version of this error here about value error. The truth value of an array is ambiguous. So stop and think about that for a second. If you have a single value that's Boolean, then you can evaluate that to true or false. But if you have an array of numbers or even an array of Booleans, does the entire array have a true or false value? It doesn't, right? So you never use AND because AND is trying to evaluate. If you look at the note at the slide here, AND is trying to evaluate the entire array as true or false, and it says I can't do that. So the AND will do an element-wise evaluation. So this just for people that just came in, this is just tidying up a point from last month's meeting where we were trying to do some like ad hoc programming, and we were confused as to whether to use AND or the ampersand. So this is true in Python as well, but especially true in Pandas. And then there's also there's a good Stack Overflow question here. Let me pop this up. And this guy here is given, if you want to look, you can look at my slides. A lot of the times I'm providing links in my slides, not that we're going to look at everything and evaluate everything here, but if someone comes along later, they can look at the slides and see the sources of information. And so this is where I got some of this information from. Let's go back to the slides here. Actually, and I always stumble a little bit with, here we go, trying to keep the Hangout presentation. This is actually going live on YouTube right now too, so forgive me if from time to time I have to decide whether I've got the right thing broadcasting. But if you look at this, there's also an operator precedence issue. And who has, like, does everybody here have some programming background? Like, if you do have programming background, put up your hand. Okay, cool. So basically, when you're doing programming, even in a math class, like if you think about, like, let's say you're going to do like 3 times 5 plus 6. Well, you can just go left to right and you can get that question right. You can go 3 times 5 is 15 plus 6 is 21. But if it was instead, and sorry, I normally would be up at a whiteboard doing this, but I'm partially trying to keep my audio good by staying near the computer, and then partially the whiteboard's blocked. But if you go 3 plus 6 times 5, if you evaluate that left to right, you get the wrong answer, because what I'm talking about here is operator precedence. In algebra, a multiplication or division comes before an addition. Well, that's the same thing, but on steroids in programming. You have something called operator precedence, and the point is that this is what I'm doing on this slide here. If you were actually to try to do something without the parentheses, we were also having trouble last month with getting the parentheses in the right place. So if you look at this line here, the second line of the slide, you notice how the ampersand has 2 things it's comparing, and they're set off with parentheses. If you didn't use the parentheses, it would actually evaluate it like this. It would without the parenthesis, it would actually take this as your left-hand argument and take everything over here as your right-hand argument. So I'm not going to spend too much time like going through the whole slide and explaining how that works, but it's something to be very aware of if you're getting into programming, and especially with Python, that when you're writing these conditional expressions in Pandas, you're almost always going to be wanting to use the parentheses to set off your. I'm sure there's an exception somebody could point out. Now, the main thing, and if anybody has questions, let me just explain. We have this microphone here. If somebody has like a quick question that I can re-summarize for people watching the video later, then I'll do that. If you want to make a more extended comment, then I would ask that you grab the microphone, and then the audio will like get to my computer better. I tried to get some wireless mic setups beyond just that one, and I couldn't. I'm a student at UVU, and I went over there yesterday and no mics. So anyways, so if you have questions, don't hesitate to just stop me and jump in, or if you have a comment, then don't hesitate to just put up your hand. And again, if it's a longer comment, I'll have you use the microphone, please. And the other thing is I don't tend to run around to do introductions, because especially if you have bigger groups, it just wastes a bunch of time, and we can all network afterwards or on the break. This goes till 2 o'clock. We'll take a 15-minute break, and then there'll be for people watching the video, there's a different video about machine learning that will be our 2:15 to 3:30 hour. Okay, so Jupyter Notebooks, and then so I always try to ask the positive question. Like if somebody says, "Who's never done programming?" I'm like, or "Who's never studied rocket science?" Well, I've never studied rocket science, and I don't really want to admit that, right? So I may not put up my hand. But who is familiar with Jupyter Notebooks? Okay, so we got some familiarity. So I just wanted to go through some different things, and a lot of what I'm doing today is being pulled from a Coursera course. There's a course. Let me see. I think I refer to it here. Somewhere I refer to it, probably in the notebook. Let's go look at the notebook real quick. In this notebook, where is it here? Week 2. I'm crediting the work of this class here, Coursera Applied Plotting, Charting, and Data Representation. And I put some of my own notes in there, but if you were to sign up for this class, they have a Python for Data Science series that if you're already familiar with Python, then it's a really good place to start and learn about pandas. And they have some challenging assignments. Now, the first thing I think I was going to talk about here, let me go check my slide. I think people at home can see me switching windows too. Okay. Matplotlib is it's a plotting library. If anybody's ever heard of MATLAB, a lot of people are familiar with MATLAB, and the people that were doing the plotting libraries or using a lot of MATLAB wanted a solution for Python. So they brought it over. There's this white paper on architecture of Matplotlib. I'm going to hit the highlights. It's not really something that you need to know 95% of the time. And I might actually close, I think I'll close those. Do you mind closing those? Yeah, I think, or just leave one open or something. We'll see how that works. I don't know if anybody knows the second line, like, so the point of Matplotlib is, I mean, a lot of you guys aren't old enough to remember the world when there wasn't like a consistent windowing system. Like you didn't have Java where you couldn't write like one program and have it show up on all your different systems. You couldn't have it, you have to write a different set of code for a Mac versus a Windows machine. You would have to write different code if you were displaying in X Windows, which is the windowing system in Linux. I don't know if they still call it that. I think they call it GTK now, but what Matplotlib and what a lot of things are doing is giving you one consistent interface, so you don't have to think about how your application is going to show up on all these different platforms. Now, these are GTK, Qt, TK is really old. TK is like part of, it's not part of TeX. I forget if it came out of the original Unix systems or it might even go back further than, but it goes back to like the 70s or something. There's all these different ways of drawing things on screen, and you really don't want to care about that. You just want to have a consistent set of commands to do plotting. You know, it's this big buzzword in data science called visualization, and you don't want to have to think about you don't want to have to think about drawing to a particular pixel on the screen, or you don't want to care about knowing how big your screen is. You want to abstract that away. So this is what Matplotlib at one layer does. I forget where Coco's from, and WX widgets I think is an older windowing system for Python. But that's the point of that line in the slides, is that you're not having to worry about that line. Matplotlib has these 3 layers, and you're pretty much always going to be working in the scripting layer. We'll look at the backend layer in a minute here. And then the artist layer is sort of what sits in between the commands that you write and the back end, and figures out how to like if you have a graph, you could break it down into components, right? You would have a set of axes. You would have, you'd have your labels. There's all these like hierarchical elements of a graph that have to be kept track of. So we're gonna flip back and forth between slides and then some examples in the Jupyter Notebook. Let me just see in the notebook if I had something at this point to look at here. I think I'm gonna talk about this for a second. So I don't know if anybody has noticed this. You kind of take it for granted that Jupyter Notebooks, they start with Matplotlib. Is that big enough that everybody can see that? Let me make that a little bigger. If you get old like me, you got to like sit in the front row and wear glasses. So this is probably a little better. And are you able to see this on your screen still? Is it like readable for like the home audience there? We've got a guy in the front row that's being helpful here, kind of. Yeah. Okay, good, cool. If you check that occasionally and let me know if I've done something really bad, and we'll fix it. And for anybody that's actually watching this live, which I don't know that anybody is, I'm not really paying attention to any comments on meetup.com. Oh, cool. Okay, awesome. Oh, very cool. I appreciate that. Thank you. Yeah, it's hard to present and pay. I think I said this before. It's hard to like stay focused on the presentation, plus try to run the Hangout and pay attention to comments. So last month, somebody actually commented on meetup.com like, "Hey, you got the wrong camera on," and I didn't see that till 2 hours later. So that was bad. So for 10 minutes of our last presentation, I was like, some guy had his camera focused on his outlet or something, and that's what people got to see instead of that they could hear, but they couldn't see. Okay, so back to the point. You have this line here, Matplotlib notebook. This is what I wanted to show you. I'd actually never seen that before until I started doing this Coursera course. Usually you'll see Matplotlib inline. If you just do Matplotlib, it'll just make a separate window. A lot of times you don't want that, right? The whole point of a notebook, of a Jupyter notebook, is you can have interactive code and you can actually run your code. It'll show the images. And I only learned this recently. I've been using these for over a year. But when you save the Jupyter notebook with the images showing, it actually saves those graphics. So you can actually just send that notebook to somebody. They don't have to be able to run the code. They can look at, well, they have to be able to have a Jupyter environment installed to see it in the first place. But they can actually see the results of your calculations without running the code. And if they want to, they can get in and they can tweak it. I think part of what people like about these is the reproducibility. That's like a big data science thing about reproducible experiments. There's been some pretty scandalous things where people make some big claims and then their experiment's not reproducible, and they lose face and have to go work somewhere other than academics, I guess. Well, normally you would see here inline, like if you look at where I'm pointing at here, you would see Matplotlib inline, and I'm just going to show you. Let me just run the next couple cells here. When I plot this. This is a very simple command here. It's just going to do a plot at the point 3.2. Oh, you know what? Okay, so this is something I need to focus on for a second. When you change, this isn't supposed to be the case anymore, but I'm finding it is the case. When you change this inline to like just Matplotlib or change it to notebook, you have to restart your kernel. Hey, John, how's it going? Nice to see you. Oh, no problem. So you have to go up here and restart and clear out. Well, I clear the output. I thought that changing the type of display wasn't supposed to require that, but let me do this again. So I'm running Matplotlib inline. I'm just running this here. These import statements are the important part. If you're not familiar with this, you need to import these libraries. You typically, usually people import pyplot and import it as PLT, but here we're just importing the entire Matplotlib library first, and then we're importing pyplot. Let me run this. And the whole point of what I'm showing you here is that when we run these, let's see, it's funny, tab doesn't work to get to the next cell. That's one thing I don't like about notebooks. Oh, come on now, go away here. Oh, what did I do? Sorry, bear with me. Hitting the tab brought this up, and it's actually not what I wanted there. Okay, so we're going to run that, and then when we go down to the next, here we go. Running inline, we're going to get two different graphs here. If I know, you see how there's the one graph there, and there's a reason it's not showing any data that we'll get to in a minute. If you look at this line here, we didn't give it a third command. We told it in the previous command to plot at the point 3.2, but we didn't tell it what to plot. So Matplotlib, it has some required arguments, and then it has like an almost never-ending list of optional arguments. So here we're actually telling it to use a dot for the plot. And when I run this, you'll notice it's making a second graph. Well, maybe that's what you want. Maybe every time you do an iteration, you want a new graph, and you want to have people seeing, a series of graphs that you build, or maybe you want the same graph to be modified. I would tend to think you'd want the same graph to be modified. So the way you fix that is you go back here and use Matplotlib Notebook instead. So where I have the inline, I'm going to change it to Notebook. And then I have to go and restart the kernel, and I'm going to clear the output. Yes, yes. And again, if you don't specify anything there, it'll just draw a separate window, which could be useful, but not today. So I'm going to run this with Notebook. I'm going to do these import statements again. And you notice the backend changed. I forgot to point this out, but now the backend is called nbag, which I don't know what that means. But so now when you plot, you'll notice you get this graph that has this You can actually turn the graph off. I haven't played with this too much to see what that means to stop the interaction, but it's an interactive graph. So when I run the next command, you'll notice it's not going to come down below here. It's going to actually come up in the graph. So let me just move it here. And when I run this with Control Enter, you see that dot just appeared right there? That's changing the same graph. So to me, that was kind of interesting. I never knew about that inline versus notebook thing. So let's go ahead and take a look at some more examples and some things about Matplotlib. I think I have another slide here to look at. So a little more about this artist layer. Oh, Sam joined. Hey, Sam. Welcome, Sam. This artist layer basically has your different containers and primitives. There's a list here of all the different types of objects in the artist layer, which is kind of confusing because there's an artist layer with a capital A, and then one of the items in the artist layer can be a lower a artist. And for people that have come in a little later, if anybody has a question or wants to jump in with a comment, I'm not going to get 100% of what I say right. Hopefully I get 90% right. But if you're sitting there and you're going, oh no, this guy's not quite getting this right on Matplotlib, please jump in. And I just ask that if it's a quick comment that I can repeat for the home audience or people watching later, then I'll repeat your comment. But if it's a longer comment, grab the wireless mic there and you can get up and talk for 5 minutes about something if you have 5 minutes to say. There's a tutorial on the artists right here. So PyPlot is what a lot of people tend to use. PyPlot's just an interface to the artist layer. It's an interface to the underlying layers of Matplotlib. So most of the time, like this guy that does this Coursera class, he says 95% of the time you're just going to be making commands in PyPlot, but it's the other 5% when you really want to tweak a graph and make it look a specific way that you're going to be working directly with the artist layer. It's basically a scripting layer. I think it's an interesting point. I don't know if it goes beyond theory as far as being interesting, but you issue commands in PyPlot. Like it's not, if anybody's done CSS or done any like D3 with JavaScript, there you're dealing with it like the document object model is a hierarchy, and so you're going to be like getting children and like basically working on an existing hierarchy. You can do something like that with artists, but you generally are going to be doing procedural method. You're going to be issuing command after command to build your plot. I have these links in here again, just for people that look at the slides later to look at some of the documentation. There's a lot of good tutorials. Let's just take an example look here for a second. This controlling lines property, this will just show you. Let me make this a little bigger. Again, we're going to have variables x and y that we're going to plot, and then you can give it a line width command. So this gives you kind of an idea of how you're setting up plots. You're further up here. They're going to have some examples of how to use use these triangles, and this is something where you want to keep on writing over an existing graph if you have multiple things you're plotting. So I'm showing that not to try to delve into the deep documentation of Matplotlib, but just to show that it exists. And anybody that's done any development knows that there's like this process of like you can't figure something out, you go to Stack Overflow, hopefully the question links to the documents, and you're either going to just be copying and pasting code off of Stack Overflow, which is kind of okay, but if you really want to know how stuff works, you have to dig into the documentation. So here we're doing something. Let me go back to the slides for a sec. Yeah, I'm probably not going to get into this. And then let me just look at something here real quick. Notes. God. Yeah, so I've only got one. If anybody likes Monty Python, I just had to throw that in. That's of course fair use for educational purposes. Okay, so let's go back here for a second. So when we look in here, let's just go through this notebook and see. There's a way to set the back end. You can grab a different back end called figure canvas ag, and I think this is kind of interesting. When you're working with this figure command, if you don't give it any parameters or tell it what figure to work on, it generates a new one. And don't forget, when you call these things, and the only reason we can call this without any more qualification is because we imported figure from Matplotlib. So you call it, we've got this variable here that it's a new figure. A lot of times you have to pay attention to what the return value is. You know, you'd think you just call for a plot, but a lot of times it'll return a set of axes or something you can work with. There's another command here where we make a variable called canvas is taking the figure and applying it to this figure canvas ag backend. This subplot thing here, this is just telling it to make one plot. You can actually have, when we do the second hour in the machine learning examples, we'll see where they actually do, I think it's like 16 plots in one graph. But if you're just doing one plot in one graph, you would just give it this 111. And again, I have the documentation. If anybody wants to look at this, there is a repo that's a link in our Slack channel, and you can download these notebooks and play with these. And then I'm not 100% sure why, but this is it's not going to display. It's apparently this figure canvas ag backend doesn't display. So they're actually, I thought this is pretty cool. You basically you've made this figure, you've tied it to this canvas, you're making a variable called ax for the axis and adding this subplot. So you're not actually seeing the graph. A lot of times when you're developing, you're working, you're not seeing it happen in front of you. And so they're actually calling on the canvas, which remember was assigned right here. They're calling this to print it to a file, which I actually hadn't seen that before. I thought that was pretty cool. And then if you're familiar with Jupyter Notebooks, you can actually, all these things that start with % signs are called magic. So there's an HTML magic in a notebook where you just can run HTML. And depending on what environment you're in, you sometimes have to play with the working directory. If you're running a notebook like out of PyCharm or Spider, sometimes it tries to make the working directory your projects directory. And if you have your notebook file somewhere else, you have to explicitly call some OS commands and tell it to change the working directory. But in this case, the working directory is where it saved the file, so we don't have to give a qualified path name. And you'll see it's just going to show this. And it's not that fancy at this point, but it's just showing one functionality of how you can write files out and not have to depend on displaying them right in front of you. Now there's another example here, and let's see what this is going to do here. Creating, and again, we're going to keep working on the same graph. This is just mostly showing that you can set the axes. So we're creating a new figure here out of pyplot. We're calling the plot function. And again, this is working on that scripting layer. We're not digging down and modifying the actual elements. We'll take a look at that in a minute. But you're telling it to plot with a circle this time with the O. And then you're giving it, we'll look at this plot.gca in a second, but you're giving it the axis, 0 to 6 on the x-axis, 0 to 10 on the y-axis. And you can see how that shows up. So this just give me, I know that Tanner and Sydney, especially Sydney, did some stuff with Matplotlib last month, but I think a lot of people didn't see that. And so to the extent that I'm overlapping with hers, it's worth seeing again. And I think the Matplotlib notebook thing to me is the most cool part. I really like being able to just keep writing to the same graph. And you'll notice that, oh, sorry, lost my place there. There's one more example, and then we're going to look at what generators are. It's a little different subject, but it comes back to Matplotlib. Sorry, I should be using my mouse, and I'm used to having a big screen at home, and so it's always a little challenging to work on these little laptop screens. If you're young, you have good eyes, and it's easier, and actually, if you're young and you have a good neck and you're good back, you can hunch over like this all day long, and it doesn't hurt, right? So there's another example here, using a circle instead of the dots. And what you're seeing here is it's also picking on some different colors. Let's see, now where do the colors come from? I think the color examples are later. I think that's happening automatically somehow. So sorry, I don't have a better answer on that. And then the last thing you want to, this is just reminding you that there is a bunch of stuff going on in the background. If you look at the AX object, look at all the elements that are going to make up this graph. There's lines, spines. I'm not 100% sure what that is, but you have an X and Y axis. You have text on there. So you can actually, if you want to get to the lower level, you can actually get at all these elements using this GCA function and getting children. But it's a lot easier just to write commands to PyPlot and let it handle the work. But there are examples where you want to dig deeper. So it's good. It's a good thing to know about. Now, scatter plots here and zip generators. Is anybody familiar with iterators in Python or iterators in general, where you have something called lazy evaluation? Like you have any C++ people in here? I've done C++ too. So when you see this, it kind of looks like a pointer, but it's not a pointer. But you have things that are, a lot of times in functional programming, there's things that are called lazy evaluation. Like you might have a generator, you might have a list you want to create sometime, but you're not ready to create it yet. So I just thought this came up in this Coursera lesson. I thought it was an interesting point to look at. These zip generators, if you know list comprehensions in Python, if you don't know what a list comprehension is, that's like the first thing you should go home and study. If you ever see in Python, like something in square brackets that says like for X in Y, it's a little cryptic until you understand Python, and then that's exactly how you want to write things. You don't want to use, it's another case where you don't use for loops. You just generate lists with comprehensions. And so this lazy evaluation is going on here. Well, let me just run this first. So we've got the scatter plot here. And you notice that here we're just creating a NumPy array, right? We're just creating the array. The array's in memory. It's called X. We're setting Y equal to X. And it's a simple plot. It's just for an example purpose of how, the point of that was just to show you that you can make the array, and there it is. And if your array only has 8 elements, then who cares? You got a couple gigs of RAM to play with, or I don't know. What does your Mac have, like 8 or 10 gigs or something? Yeah, so I think I've only got 6 on this one, and anybody like me that started out with an Apple II, you had like 64K of RAM, and so it's nice not to care about memory. So there's another example here. This is going to show some of the colors, and then we'll get into these zip generators. So you notice we're making an array again here. You can actually make another list here. You notice, and this is called broadcasting in Python. You're making a list of one item, and then you're multiplying it by, like if it's if you want a 10 element array. Let me think how that's working there. I don't know why it's doing the -1, but basically you're taking a single element and broadcasting it means multiply it. If that's going to turn out to be, let's see, X is what, 8 items long. Does anybody have an idea of why you would want? Oh, I see what they're doing, because they want red as the last color. Sorry. Normally you wouldn't do the -1. You would just say, let's make all the dots green. Let's make them. We'll have a list of colors equal to the length of this array. But here they're actually doing it. It's going to be 7 long, and then the last color is going to be red. And this is another option for Matplotlib. You can, and Sydney did, I think Tanner maybe to some extent, but Sydney did a great job with this last month. If you haven't seen that, you go back to the number 2 video and watch like the last half hour of it. And Sydney did some cool stuff with, there's all these pre-made color sets. Like people, like I have no artistic talent, so people with actual artistic talent and like an eye for design have created much nicer color sets than I ever could. So you can, and they're public domain, you can go grab these color sets. But for now, we're just going to use something simple. And you'll notice, and because we're doing Matplotlib Notebook, it worked on this. And you notice now this has this red dot up here. Well, if you have a lot more data to work with and you don't want to generate the data until you're actually ready to use it, use these. Okay. So first of all, you can zip things together. If you know what a tuple is. Like if you look at Cartesian coordinates, think back to your geometry class. If you have a graph and you want to graph it, the point 2 on the x and 3 on the y, that's called a tuple, right? It's in parentheses. It's going to be a 2, 3. And so if you have 2 arrays of x values and y values, and you want to make them into tuples, because there are certain things that want to work with Cartesian coordinates, you zip them together. But the zip function actually doesn't make the actual array. You'll notice here. If I run this, I'm just going to run this for you here. And you'll notice that we use zip generator equals, and we zip these 2 arrays or lists together. If I just say print zip generator, this is a little reminiscent of C++. It's not actually pointing you to the list itself. It's pointing you to this object in a certain memory location. It's the first print command just says, oh, it's just a zip object. You have to actually convert it into a list. And again, this is going to work really good if you have like big data sets and you don't want to have them in memory any longer than necessary. For an example like this, it's just purely for example. But when I print the list generator, or I make the zip generator into a list, you actually get the contents here. Now, I don't understand why. If anybody has any ideas, please speak up. But for some reason, when you use a generator in Python, it goes away. It's only usable once. So if you want to keep it, you'd have to assign it to some kind of a variable. There's ways to use T. Like I've got, you notice here, in this one here, I actually printed I made a list out of it and printed it. And then a little further down, use the star to unpack, like instead of using the list command, you use the star to unpack the actual values. But you notice down here, it didn't print anything because that's already been used up. And it doesn't print an error, that's nice, but if you're trying to debug, maybe that's not so nice. But you'll notice here, if it's not going to print anything off the first one here. Print list. Oh, it does because I'm calling zip again, and then making a list out of it and printing it. And then I run the generator, and then this is just showing how you can actually, and if you're familiar with this in Python, I don't know that Java does this. Like I've worked in Java, and maybe it does. I don't really recall using this much, but some languages you can actually return two values and assign it to two variables. Does anybody know, like C++ doesn't let you do that, does it? Yeah, and I think Java doesn't. I think it's more of a, like functional languages or Python that does this. And so when I print the X and the Y, it's basically, it's getting the set of tuples back and then just printing the elements, the X elements and the Y elements. But I think the generators have a use. I just wanted to show that off. And we're getting pretty close here. We got about 8 minutes left until we're going to take a break. If anybody has any questions, just jump in. So this one here is just showing a little more. And again, sometimes I'm doing stuff to show you things live, and other times I think these are useful. If you want to look at this deeper, you can get these notebooks from a GitHub repo. It's actually github.com/provolab/ under basic machine learning, but that's in our Slack channel. So if you want to join the Slack channel, you can see that. But this is just showing another way to do scatter plots here. There's more stuff on axes. You have, and again, this is just showing the iterative, like when they say it's not a hierarchical thing, you're not, you're stepping through and effectively issuing commands. We have a plot, we want the X label to be this, we want the Y label to be this, we want the title. You can set up a legend. There's more complicated examples in here. Like this guy in this lesson, he was showing how the legends, sometimes if you have date time, they're too wide and they get cut off. You can actually rotate them 45 degrees. You can do a lot of really cool stuff. I think Matplotlib is something good for people to know, but it's not my favorite part of data science. I kind of like more back-end calculations. I think there's people that are more into the visual and display end of things. John, have you've played with this stuff a little bit. I mean, what's your preference?
I actually like the Seaborn.
Oh yeah, Seaborn. You mean for the data set and all the different, yeah. I think we get into one of those. It's not Seaborn, but we get into some data set in the second hour here. And then these are just, I'm just going to wrap up here in the next few minutes and just show you, these are, different things you can do on the axes and the legends. This doesn't actually produce anything. This just takes this plot object and sets some parameters. It's going to add a legend. We're going to set the location on the legend here and the title. Let me look. Actually, I'm sorry. It is actually, I have to look back up. This is maybe one case where you'd want to use Matplotlib inline and keep on drawing a new graph as you go down. But you notice it's added this legend down here. It's put the labels on, and the legend actually has the label information that we gave it for tall students and short students. Go a little further down, you can run this get children and see all the different objects that make it up. What is this doing here? Get the legend from the current axis. So I thought it was interesting how in this lesson, this guy is combining getting the elements. Oh, John Nelson, there we go, cool. You get the elements and you can get the children and look at like the last two elements and you're getting the axes. Oh, is that gonna work? I'm not sure why that's not outputting here. And then there's a section in here on line plots as well, so you can kind of see how to do line plots. It's pretty cool when you start doing comparisons. I think we're going to actually shade this area in between here. I'm going to set some labels on the graph. So you see the labels appeared there. Change the, oh, where'd it go? Let me use this mouse. It's better to have a scroll wheel. Oops. Okay, here's our line plot again. So you notice the legend got added to it. The shading in between here is doing this fill between command. So this can be pretty helpful. And so there, whatever you can imagine doing on a graph, you can probably find in Matplotlib. I think that helps some representation. In the next month, I'm actually going to do a little more. We're going to wrap up here, and then we'll do at 2:15. I'll start the machine learning end of things, and we'll actually be looking at this paper called "To Explain or Predict." I don't know if anybody saw the notes on meetup.com. But the first part, and I have a lot of slides that repeat the text of the paper. We're not going to stop and like read through the whole paper, but we're going to hit the highlights. And then we're going to do some basic machine learning on clustering, explain the math behind clustering. Next month, I'm going to maybe do something on, clustering is what's called an unsupervised algorithm. It's you don't lay a structure over your data. You let your algorithm discover the structure. I'm having a senior moment here. It's clustering. What's the supervised method? Classification. Yeah, maybe next month I'll do something on classification. But for now, if anybody has any questions, I'll answer them. Otherwise, I think I'm just going to look and see if there's anything else we need to look at here. Everybody wants to run home and use this now, right? I mean, has anybody done extensive work with Matplotlib? And to me, it seems like you could really beat your head against the wall on this kind of stuff. Let me just look and see what the rest of his examples here were. I don't recall exactly what he's doing at the very end. We got the fill between command. Oh yeah, and this is something. We'll look at this real quick. He's actually, if you look at the graph, it just has the numbers on the bottom, and he actually wants to go to. Oh, there we go. I'm sorry. It just has numbers on the bottom. He actually wants to go to a date range here. Sorry, there we are. And I'm not going to try to explain all this in the next few minutes, but let me run some of this here and see. Is it still running? I guess it's still running. Nope. What's going on here? Here we go. Yeah, let me just run some more of these. You notice, so this is, just to wrap up, this is what I was showing you, and if you want to learn how to deal with these problems, you'd look through this notebook more. He's printing this date ranges and they're overlapping. You can do something called, you actually get the tick labels and you can modify those and rotate them. And you notice now it's actually, you see how it's changed those dates and rotated them. You can change the bottom because they were actually hidden, and now you can actually, if you notice in the last one, the years were partially hidden. And then the last part here, let me just run these two here. So you can start out with some pretty ugly graphs and get to some pretty interesting stuff. He put the title on the top there, and yeah, I think we're going to wrap this up here. It's 2 o'clock, so we'll take a 15-minute break and start up again at 2:15, and I'll cut off the video and then start another a different hangout at 2:15. And if anybody has any questions, let me know.